Hello everyone, my name is Abhishek and welcome back to my channel. So today is episode 2 of the Gitops and Argo CD series that we are doing, and this episode is personally my favorite because in this video we are going to understand the architecture of these Gitops tools, whether it's Argo CD, whether it's Flux CD. Watching this video, you will be able to understand how Gitops controllers are built, and you can easily switch from one tool to other tool in the future. And you can also explain the concept of Gitops to anyone. So watch today's video till the end because this is going to provide you in-depth understanding of Gitops. Okay, now what we are going to do today, I'm going to explain you in couple of minutes. But before that, if you haven't watched part 1 or episode 1, it is highly important for you to watch part 1 before watching part 2, because in part 1 I explained you what is GitOps, why GitOps, I mean why you should use GitOps. Then I explained you what are the principles of GitOps, like when you can call a tool as a GitOps tool. Like, can you call Terraform as a GitOps tool? Why you can call Argo CD as a GitOps tool. So these are some of the things that I have explained. Now, in today's video, I'm going to talk about some of the popular GitOps tools. Then we will take one particular tool. I know it's not any more suspense. We will take Argo CD and we will try to break down high level design of Argo CD so that you can understand any GitOps tool going into the future. Now, firstly, let's start with what are some of the popular GitOps tools. So some of the popular GitOps tools that are in market right now. One, I mean, number one, obviously, Argo CD. Argo CD is the popular GitOps tool that's available. I'm going to also do comparison between Argo CD and Flux CD because many of you are asking about it. So, few people debate that Argo CD is better or Flux CD is better. So I'm also going to put my point on it. But for me, Argo CD is one of the best GitOps tools that is available in the market. Then you have Flux CD. Then you have Jenkins X. Then you have Spinnaker. So again, some people might say Spinnaker, but Spinnaker fundamentally is a deployment oriented tool. So it's not focused completely on the GitOps. Even if you go to Spinnaker docs or even if you try to explore Spinnaker, it is a tool that focuses completely on the deployment part, but not on the GitOps part. Of course, you can do GitOps with Spinnaker, but compared to the other tools which are completely focused on GitOps and their whole design is based on GitOps, so they are much better than Spinnaker. So Argo CD, Flux, Jenkins X, and Spinnaker. So these are popular tools in the GitOps space. Now, what are we going to learn in this entire series? Going ahead, where I'm going to demonstrate some GitOps things and all. So what we are going to do is we are going to learn Argo CD. So some basic history of Argo project. I'm not going to take much time here, just 30 seconds. Initially, Argo CD was created by engineers at Appletics, and then they have open sourced it. Right now, Argo CD, the entire Argo project is open sourced. You have Argo rollouts, you have Argo CD, Argo events, Argo workflows, Argo notifications. You have lot of things. Okay, then of course, Appletics was acquired by Intuit, and then there are very active contributors to Argo CD, which is one of the core strengths of Argo CD. You have people from Equity, BlackRock, CodeFresh, Intuit, Red Hat, in the order of, I mean, I just place the company names in the alphabetic order. There is no significance of one company contributing more or one company contributing less. So Equity, BlackRock, CodeFresh, Intuit and Red Hat. These are the top contributors. And now it's a CNCF graduated project along with Flux. So Flux is also CNCF project. And Argo CD is a GitOps tool that has 13K plus stars. So you can understand the popularity. I'm not going to deep dive anymore in the history. So let's quickly try to understand this entire thing about a GitOps tool. Okay, so this first slide that I'm going to show you in a nutshell, like if you want to understand GitOps, so you can understand that, okay, any GitOps tool you can place instead of Argo CD, you can place the picture of any other GitOps tool there. And what it does on a high level is that it tries to maintain sync between your Git or your version control system. In previous class, I told you that for GitOps, even though the name is GitOps, it does not have to be Git all the time. It can be any version control system. So on a high level, this GitOps tool, whether it's Argo CD, Flux CD, Jenkins X, what they try to do is they try to maintain a state between Git and Kubernetes. That means they use Git as a single source of truth. Whatever is in Git is considered as the truth for GitOps, and they just take this manifest from Git and they deploy it onto the Kubernetes cluster. And after deploying, let's say there is application A, application B, the deployment manifest in a Git repository. So this GitOps tool pick these deployment manifests and deploy them on the Kubernetes. And after that, they continuously try to watch the state between both of these things, between Git and Kubernetes. Let's say someone manually logged into Kubernetes, modified something. Argo CD will say, no, I'm keeping a state between both Git and Kubernetes. So someone has modified you. Let me go and correct you according to the manifest in Git. So what is the advantage here? If you are doing a traditional deployment, if you are doing a traditional continuous delivery model, then you don't get this auto healing capability by the shell scripts or the Python scripts that you are using in your Jenkins pipeline, GitLab pipeline, or any other thing. Whereas by using this GitOps tool, because it's a Kubernetes controller, most of these tools are Kubernetes controllers, and they are very much focused on Kubernetes. So what they do is they do the reconciliation logic. So in Kubernetes controllers, reconciliation logic is nothing but keeping state between your A and B. So A in this case is Git, B in this case is Kubernetes itself. So a Kubernetes reconciliation logic can be between any two entities. In this case, in case of GitOps, it's between Git and Kubernetes. Okay, now you might feel that, okay, it's very easy, but okay, I'll come to the installation part later, but let's try to break down the architecture a bit. Okay, so in this slide, you might feel that, okay, it's keeping sync between Git and Kubernetes. But if I try to break down the architecture more, let's try to see that there is Git, there is Kubernetes. Now, if you are trying to build a GitOps tool, or if there is any GitOps tool in the market, the first thing, like I told you, it has to keep state of Git. So for that, it has something called as a repo server. Now this architecture is focused on Argo CD. So I'm going to talk about the Argo CD architecture. But if you understand this architecture, you will understand architecture of any GitOps tool. So what does this repo server do is it will try to connect to Git and get the state of the Git. Okay, so one component, or if you consider GitOps as one application, so this is one microservice inside the GitOps application that is talking to Git. Then there has to be another microservice that should talk to Kubernetes and get the state, right? So in Argo CD, we call it as application controller. So what application controller is doing? It is talking to Kubernetes and getting the state of Kubernetes. Now, why you need both of them? I just explained that you have to maintain state between Git and Kubernetes. So that's why there is one microservice which is getting the state from Git, and then there is another microservice which is getting the state from Kubernetes. And after that, what happens is this application controller here will get the state from Git and try to compare. Okay, so what you got from Git and what I have from Kubernetes, is it same or not? If it is same, then perfect. I mean, everything is right. If not, then this application controller will try to sync the things according to the manifest or according to the state that this repo server has got onto the Kubernetes cluster. Now you might again feel that, okay, this is done. I have something that gets me the state from Git. Then I have something that gets me the state from Kubernetes. So there are two microservices in a GitOps application. But now you might have these services, but as an end user, you want to talk to the GitOps application, right? So if you want to talk to Amazon, then you have Amazon UI, then you have for some CI based application, for example, Jenkins, you have Jenkins UI and then you have Jenkins CLI. Similarly, even for Argo CD or any other GitOps tool, you need to have UI and CLI based solution. So in case of Argo CD, that's called, if someone, a happy user, is trying to connect to Argo CD from UI or CLI, there is one component called API server. Okay, or you can at least call it as server as well. Okay, so there is API server which is used by the users to communicate to Argo CD using the UI or CLI. Okay, so this way now you have three components. These are called three microservices. One microservice is for the user interaction. One microservice is for getting the information from Git. One microservice is getting for the information from Kubernetes. Okay, then this API server should handle authentication. This API server, in case of Argo CD, has the capabilities of single sign-on, has the capabilities of integrating with your existing OIDC providers. Let's say in Jenkins, you can connect existing LDAP, right? You can connect any external database, that's the user login database. So similarly, what this API server says is I can get information from any uh, external things. By default, when you install Argo CD, Argo CD comes up with Dex server. Okay, so Dex is a very lightweight OIDC. You can consider it as a proxy server which can connect with any of your existing providers. Let's say in your organization you have Google, in your organization, I mean Google is Gmail, you have Gmail authentication, or you have Facebook authentication, or you have any other things, you can integrate them with Dex. Okay, so this is used for OIDC or OAuth authentication. You can simply consider it as SSO capabilities for API server. Okay, then finally you have Redis, which is for caching. Why you need to cache everything is because, let's say for some reason this application controller went down. Now once it comes up, it need to have information of what has happened or what is the information till now on the cluster. So that's why this application controller is a stateful set, and this Redis is used for caching the information. So this is the architecture of a GitOps tool. So overall, whatever you see between these yellow lines is the architecture of GitOps tools. One is a repo server. You can consider this as an exact configuration for Argo CD, but similarly for Flux CD or any other GitOps tool, you will have a similar architecture. Okay, so you have repo server which is talking to Git, you have application controller which is talking to Kubernetes, and these two gets the information from two entities and try to compare the state. Okay, so application controller gets this information from repo server and it tries to always try, I mean, it always tries to see if the state in Git and Kubernetes is same or not. Now, then you have API server that is used for the UI or CLI authentication. Then you have Dex, which adds the SSO capabilities. So in case of Flux, you might have something else, but more or less the configuration would be same. I mean, the architecture would be the same. Then you have Redis, which is for caching. Why you need caching? Because these are stateful sets. These applications have to be stateful sets and they have to cache the information. So this is the architecture of GitOps tools. Now, when you see this, you might feel that, okay, it's very easy. On the previous slide, this might look very easy for you, where you say that there is a GitOps tool like Argo CD, which keeps a state between Git and Kubernetes. But if you try to understand the architecture here, then you will understand that, okay, there are a lot of microservices which is doing things underlying for you to get this robust system called Argo CD GitOps system, right? I hope this architecture is clear. Now, apart from this, what you have is the, okay, if I just minimize these slides, you know, you have the installation part for this Argo CD, where you can install Argo CD using YAML manifest, you can install using Helm, or you can install using Kubernetes operators concept itself. Okay, so in the next class, I'm going to talk about this installation part, and we will do a live demo. We will take one application and we will try to deploy the application onto the Kubernetes cluster. Okay, so then we will try to understand some details of GitOps, where how we install a particular application onto a Kubernetes cluster using GitOps. And then I will provide you some underlying insights. Like during the interviews, this can be the questions that interviewers will ask you. For example, what happens? Okay, you keep saying that in GitOps, Git is a single source of truth, or Git is a simple source of truth. But now let's say I'm giving you a situation where you have pod.yaml in GitOps. I mean, in a Git repository, and GitOps tool picks this and deploys it onto a Kubernetes cluster. Now, what if, okay, what if there is an admission controller that is adding resource requests and limits to these pods? Will a GitOps tool remove these things? If it removes, then your pod deployment will fail, because you might be in a cluster where resource requests and limits are mandatory. And some admission controllers keeps adding annotations, labels, or anything like SCC to your pod, any specific thing. So now how does GitOps handle this kind of things? That we will try to understand. And then I'll also tell you how to, like, let's say you have decided to onboard GitOps in your organization. But in your Kubernetes cluster, you already have a lot of resources, right? Let's say you have two applications already deployed even before trying to use GitOps. So will GitOps delete those applications because they are not in Git? So in such scenarios, how to use GitOps? And these are some of the underlying concepts. Again, you will not find this in many places. So I'll try to explain these things in the next videos as well. Thank you so much for watching today's video. I hope you enjoyed the architecture of GitOps. And in future, I'll be doing more such videos. So if you want to get these interesting updates, please subscribe to my channel, Abhishek Veeramalla. Thank you so much. See you all in the next video. Take care.